Let us start exercise 6B of ICSE class 10th mathematics, ratio and proportion. Question number 1. If x by y is equal to p by q, prove that 5x plus 7y by 5x minus 7y equal to 5p plus 7q upon 5p minus 7q. You see, it is given already that x by y is equal to p by q. So just to multiply 5 by 7 to both the sides, you will get 5x upon 7y. On the right hand side you will get 5p upon 7q. Applying componendo and dividendo, we get 5x plus 7y whole upon 5x minus 7y equal to 5p plus 7q upon 5p minus 7q. Proved. Now proceed to the question number 2. If in bracket 4a plus 9b is to 4a minus 9b equal to 4c plus 9d is to 4c minus 9d, so that a is to b, same ratio c is to d. You see, first of all, the given statement can be written in this form also. 4a plus 9b upon 4a minus 9b will be equal to 4c plus 9d upon 4c minus 9d. Applying componendo and dividendo, we get, you see, 4a plus 9b plus denominator part, that is 4a minus 9b. In the denominator we will have to write first a numerator, that is 4a plus 9b, minus denominator, that is 4a plus 9b. Once you are going to minus it, so it will become minus and this will become plus. So I have written here. Similarly, on the right hand side also, 4c means the numerator, that is 4c plus 9d, plus denominator, that is 4c minus 9d, whole upon 4c plus 9d, that is numerator part, minus denominator, that is 4c plus 9d. You see here 9b and 9b, this is plus, this is minus, both will be cancelled. In the denominator part also you see 4a minus 4a, these two will be cancelled. Similarly on the right hand side, 9d in the numerator part, 9d and minus 9d will be cancelled, and the denominator part, that is 4c and minus 4c, will be cancelled. So we are left here 8a upon 18b equal to 8c upon 18d. This can be, both sides can be multiplied by 18 by 8. So as soon as you multiply it, these 8 and 18 and 8 and 18 both will be cancelled because it has been multiplied by 18 by 8. So we are left here a by b is equal to c by d. This implies that a is to b, same ratio, c is to d. Proved. Now the third question. If 5a plus 11b into 5c minus 11d equal to 5a minus 11b in bracket 5c plus 11d. You see, there is a multiplication sign. There should not be ratio sign here. Otherwise it will be very difficult to prove. It will not be proved. But in the books, on the left hand side the ratio sign is given. On the left hand side it is multiplication sign is given. But in book there should be amendment that it should be multiplied. Both should be two factors. Product of the two factors. On the right hand side also the both should be product factor. So we can easily take it in the form of fraction also, like this. You see 5a plus 11b whole divided by, you see, you can bring this one 5a minus 11b to the denominator part, and 5c plus 11d, 5c plus 11d whole upon, you see, 5c minus 11d. On cross multiplication you will get the same thing. But as soon as you have arranged like this, now it is in the form of ratio and proportion. Hence we can apply the componendo and dividendo. As soon as you apply the componendo and dividendo, you see the numerator part plus denominator part upon numerator part minus denominator part. You see similarly on the right hand side also, numerator part means 5c plus 11d plus 5c minus 11d, means numerator plus denominator. In the denominator part, numerator minus denominator, that is 5c plus 11d minus 5c plus 11d. So you see this 11b plus and minus 11b will be cancelled. In the denominator you see 5a and minus 5 will be cancelled. Here 11d and 11 minus 11d will be cancelled. In the denominator, that is 5c and minus 5c will be cancelled. So here we are left with 10a upon 20b, 22b. 10, you see, 5a, 5a. So 10a upon 22b, 11b and 11b. Similarly on the right hand side, 5c and 5c, that is 10c, and 11d and 11d, that will be 22d. This complete means left hand side and right hand side both will be multiplied by 22 by 10. On multiplication you will get a by b is equal to c by d, and it is now proved. Now proceed to the question number 4. A, B, C, D are in proportion if m a square plus n b square is to mc square plus nd square, same ratio ma square minus nb square is to mc square minus nd square. This implies that ma square plus nb square whole upon mc square plus nd square will be equal to ma square minus nb square upon mc square minus nd square. By alternando, we can get, you see, ma square plus nb square. So this side, this portion, numerator part will come here and this denominator part will go there, you see, by alternando. By ma square plus nb square whole divided by ma square minus nb square. Now mc square plus nd square upon mc square minus nd square. Now by componendo and dividendo we can get ma square plus nb square plus ma square minus nb square whole upon ma square plus nb square minus, that is the denominator part, that is ma square plus nb square. mc square on the right hand side, you see mc square plus nd square, this is the numerator part, plus denominator part, that is mc square minus nd square whole upon mc square plus nd square, that is numerator part, and minus denominator part, that is minus mc square plus nd square. You see, you can cancel it, nb square plus minus nb square, these two will be cancelled. Here ma square minus ma square, these two will be cancelled. On the right hand side you see nd square minus nd square will be cancelled. mc square minus mc square will be also cancelled. So we are left here twice of ma square upon twice of nb square, twice of mc square upon twice of nd square. So 2 and 2 will be cancelled. Now we are left with ma square upon nb square equal to mc square upon nd square. This complete left hand side and right hand side will be multiplied by n by m. So we will get a square by b square equal to c square by d square. Taking the square root of both the sides, we can get a upon b is equal to c upon d, that is a is to b, same ratio, c is to d, proved. Now the second part, a plus b plus c plus d, a minus b minus c plus d equal to a plus b minus c minus d into a minus b plus c minus d. This can be written here a plus b plus in bracket c plus d whole upon a plus b. You see this one, a plus b minus I have taken out common, so in bracket c plus d is equal to a minus b plus in the second bracket, that is c minus d, c minus d. Now a minus b minus c minus d, you see this one portion, this portion will come here, a minus b minus has taken out common, and in the bracket it will be c minus d. Now by componendo and dividendo we have, now we can apply the componendo and dividendo. So the numerator plus denominator upon numerator minus denominator, you see a plus b plus c plus d plus a plus b minus c plus d, you see this one, and a plus b c plus d, this is the numerator part, minus denominator part, that is minus a plus b plus c plus d. In the right hand side, you see a minus b plus c minus d plus a minus b minus c minus d and a minus b plus c minus d minus a minus b plus c minus d. So you see the same expression are the same, the bracket, the quantity is mentioned, that is c plus d in one bracket, but it is plus, it is minus, so these two will be cancelled. Similarly in the denominator part, a plus b and minus a plus b will be cancelled. On the right hand side also, c minus d and minus c minus d will both be cancelled. Similarly in the denominator, a minus b will be cancelled by minus a minus b, both will be cancelled. So we are left here twice of a plus b, twice of c plus d equal to twice of a minus b upon twice of c minus d. By alternando we get sorry, a plus b by a minus b, you see by alternando, change the place, will be equal to c plus d, c minus d. Again applying the componendo and dividendo, you see the a plus b, that is numerator part plus denominator part, numerator part minus denominator part, numerator part plus denominator part, numerator part minus denominator part. You solve it, you will get twice of a upon twice of b is equal to twice of c upon twice of d. This 2 and 2 will be cancelled. So we are left with a by b is equal to c by d, that is a is to b, same ratio, c is to d, proved. Now question number 5. If a is to b equal to c is to d and e is to f, equal to G is to H. Prove that AE plus BF in one bracket is to AE minus BF equal to CG plus DH is to CG minus DH. So A by B is equal to C by D and E by F is equal to G by H. Given, multiplying both as per their sides, that is A by B will be multiplied by E by F and C by D will be multiplied by G by H. You see, A by B and E by F will be multiplied. The left hand side to left hand side, right hand side to right hand side. So that is why I have mentioned here multiply both as per their sides, means left side will be multiplied to the left side, right hand side should be multiplied with the right hand side. So we will get ultimately AE by BF equal to CG by DH. Now apply componendo and dividendo. Here you see AE, that is numerator, plus BF whole divided by AE minus BF is equal to CG plus DH upon CG minus DH. So AE plus BF in one bracket is 2, in other bracket AE minus BF equal to CG plus DH. In one bracket, in the second bracket it should be, the ratio sign should be there. CG minus DH, and it was to be proved, so hence it is proved here. Now question number 6, you see. Question number 6. If x is equal to 10pq by p plus q, find the value of x plus 5p upon x minus 5p plus x plus 5q upon x minus 5q. You see, x is equal to, it is given, so just split it, 5 into 2. So we need only 5p, you see, 5p into 2q whole upon p plus q. So this 5p will be brought under the x, that is x upon 5p will be equal to twice q upon p plus q. Now apply componendo and dividendo. We get x plus 5p upon x minus 5p will be equal to 2q plus p plus q. This is the 2q plus denominator, that is p plus q. Again numerator plus denominator, minus denominator here, 2q minus p minus q. So solve it, you will get here p plus 3q. You see 2q plus q, that is p plus 3q. And in the denominator you see 2q minus q, that is q minus p. So it will be first equation, you can say. Similarly, x is equal to 5q into 2p. This one can be written here also. You see 10pq, I have written here 5q into 2p whole upon p plus q. This can be further written x upon 5q equal to 2p upon p plus q. Now apply componendo and dividendo. You will get x plus 5q, x plus 5q, from you see x plus 5q means numerator plus denominator. So x plus 5q whole upon numerator minus denominator means x minus 5q. Here on the right hand side, you see the 2p, that is numerator part plus denominator part. So 2p plus pq, p plus q. In the denominator part, we will have to 2p means numerator minus denominator, that is minus p minus q. You see minus p minus q. And solve it, you will get here 3p plus q upon p minus q. This will be the second equation. Now adding first and second, we get x plus 5p. You see x plus 5p upon x minus 5p. X plus 5p upon x minus 5p plus x plus 5q upon x minus 5q. You see here the second part and the first part. We will get p plus 3q, p plus 3q upon q minus p plus 3p plus q upon p minus q. So to make the like fraction, what I have done, that I have written the complete denominator in the form of p minus q. So this portion I have written first, you see, the 3p plus q upon p minus q. In this one, what I have done, that I have written p minus q and I have taken minus common. If you just put minus inside this p plus p minus q, you will get the same thing. So solve it, you will get 3p plus q minus p minus 3q upon p minus q. Solve it, you will get p minus q. 2 will be outside and p minus q in the denominator part. Both will be cancelled and we are left with 2. So the value of this equation will be 2. So let us proceed. Question number 7. If x is equal to 6pq upon p plus q, find the value of x plus 3p upon x minus 3p plus x plus 3q upon x minus 3q. We have to find the value of this. So what you have to do, the given statement is x is equal to 6pq. So I have splitted this 6 in the form of 3p into 2q. So this 3p you can bring here as a denominator of the x by cross multiply. You see x upon 3p is equal to 2q upon p plus q. So it is in the form of proportion. As it is in the form of proportion, you can multiply, you can apply by componendo and dividendo. You can write x plus 3p, x plus 3p, x minus 3p is equal to 2q plus p plus q. You see 2q and this p plus q. So 2q plus p plus q, 2q minus p minus q. Solve it, you will get 3q plus p upon q minus p. Similarly, x upon 3q. You see from here, you can take 3q, 3 to this side and 2 to p. So x upon 3q will be equal to 2p upon p plus q. By componendo and dividendo, we can write the numerator plus denominator upon numerator minus denominator. You see x plus 3q upon x minus 3q equal to 2p plus p plus q, 2p minus p minus q. Solve the numerator, that will be equal to 3p plus q, and denominator it will be p minus q. So now adding these two, we will get x plus 3p upon x minus 3p plus x plus 3q upon x minus 3q. will be equal to 3p plus q, 3p plus q, you see 3p plus 3p plus q upon p minus q. Here in the denominator part, you see, we have to change it little bit. 3q plus p upon p minus q. You see, this q minus p can be written as p minus q, and minus has been taken out common. If we insert the p minus here, it will become q minus p. But I have taken, in order to make the like fraction, means denominator should be same. So it will be convenient to sum or subtract the numerator part. So now here p minus q will be the LCM, and 3p minus p plus q minus 3q. So we will get 2p minus 2q upon p minus q. So p minus q and p minus q will be cancelled, and we are left with 2. So the 2 will be the answer for question number 7 also. Now proceed to the question number 8. Solve for x using the properties of the proportion. You see, the equation is given, that is 3x plus root 9x square minus 5 whole upon 3x minus under root 9x square minus 5 equal to 5 by 1. We can assume it. By applying componendo and dividendo, we can get 3x plus square root of 9x square minus 5 plus 3x minus root of 9x square minus 5 whole upon 3x plus root of 9x square minus 5 minus 3x plus root 9x square minus 5 equal to this 5 plus 1 upon 5 minus 1. So solve it, you will see this plus sign and this minus sign, we will cancel it, and we are left with 3 plus 3x plus 3x, 6x whole divided by twice of root 9x square minus 5, and it will be equal to 6 by 4. 6 by 4. You just do 6 and 6 will be cancelled. This 6 and this 6 will be cancelled, and 2 will cancel the 4 by 2. So we are left here x upon root of 9x square minus 5 is equal to 1 by 2. So cross multiply it, we will get root 9x square minus 5 is equal to 2x. On squaring, we have 9x square minus 5 equal to 4x square. So 9x square minus 4x square equal to 5. So the 5x square will be equal to 5. Therefore x square is equal to 1. So x is equal to 1. Second part, you see, the root x plus 2 plus root x minus 3 whole upon root x plus 2 minus root x minus 3 equal to 5. By applying componendo and dividendo, we get, you see, the root x plus 2 plus root x minus 3. This much is the numerator part. Now plus denominator part, that is x plus 2, root x plus 2 minus root x minus 3 whole upon numerator part, that is x plus 2 root x plus 2 plus x root x minus 3 minus root x plus 2 plus root x minus 3 will be equal to 5 plus 1 upon 5 minus 1. You see, this plus and minus sign will be cancelled, complete. Here this x plus 2 and x plus 2 will be cancelled. So we are left with twice of root x plus 2 upon twice of root x minus 3 equal to 6 upon 4. You see, 6 upon 4, 5 plus 1, 5 minus 1, that is 6 upon 4. This 2 will cancel the 6. 2 and 6 will be cancelled. Here it will be 3. So here 2 to the 4. So this 4 will be also cancelled. So 3 by 2. So on the left hand side we are having root x plus 2 upon x minus 3. Root x minus 3 is equal to 3 by 2. Squaring both sides. You will get x plus 2 upon x minus 3 is equal to 9 by 4. And just by cross multiply it, you will get 9x minus 27. 9x minus 27 is equal to 4x plus 8. Solve it. 9x minus 4x, that will be the equal to 27 plus 8, that is equal to 5x is equal to 35. So the x will be equal to 35 by 5, that is equal to 7. This will be the answer. Now proceed to the third part, that is x cube plus 3x upon 3x square plus 1 equal to 341 upon 91. By applying componendo and dividendo, we get x cube plus 3x plus 3x square plus 1 whole upon x cube plus 3x minus 3x square minus 1. And this will be the 341 plus 91, 341 minus 91. You see, this can be factorized also, or you can say it is a cube of x plus 1 whole cube. X plus 1 whole cube. So here I have factorized it, or you can just make the cube also. If you know a cube, a plus b का whole cube, or x plus 1 का whole cube, x plus 1 raised to power 3. So you will open, you will get this thing. Here also I have done in this way, that is x square, x plus 1, 2, 2x and x plus 1. You see, on seeing this, the x plus 1 will be one of the factor, because the odd power, the coefficient of odd power of x. You see, 1 and 3, 4, and this is equal to 3 plus 1, 4 again. So the coefficient of, sum of the coefficient of odd power of x is equal to the rest of the coefficient, is equal to the sum of the rest of the coefficient term will be equal. So we can say that x plus 1 will be one of the factor. Similarly, in the denominator, here you see sum of the coefficient of all the terms is equal to 0. Therefore, x minus 1 will be one of the factor. So x square x minus 1 minus 2x x minus 1 plus x minus 1. You see, just take out common, and x square plus 2x plus 1, x minus 1, x square minus 2x plus 1. This is the square of x plus 1 whole square. This is x minus 1 whole square. So ultimately we will get the same thing, that is x plus 1 whole cube, x minus 1 whole cube. On the right hand side, you see, we will get 216. 216 is the cube of 6, and 125 is the cube of 5. So I have written here the cube of 6 upon cube of 5. Taking the cube root of both the sides, so we can remove this power 3 After just write down the taking the cube root. So x plus 1 upon x minus 1 will be equal to 6 upon 5. Cross multiply it, you will get 6x minus 6 is equal to 5x plus 5. That will be x is equal to 11. Now come to the fourth part. Here root x plus 1 plus root x minus 1 whole upon x plus root x plus 1 minus root x minus 1 is equal to 4x minus 1 upon 2. Applying componendo and dividendo, we get root x plus 1 plus root x minus 1 plus, now the denominator part, that is root x plus 1 minus root x plus 1 x minus 1 whole upon root x plus 1 plus root x minus 1 minus root x plus 1 plus root x minus 1. You see, in the numerator part, this and this both are same, but the signs are different. That is why it has been cancelled. Similarly, in the denominator part also, you see x plus 1, root x plus 1 and minus root x plus 1. One is positive and other is negative, both will be cancelled. On the right hand side, you see 4x minus 1 plus 2, 4x minus 1 minus 2, that will be equal to 4x plus 1 upon 4x minus 3. So, taking the twice of x plus 1, root x plus 1, and the denominator also twice of root x plus x minus 1, and on the right hand side we will get 4x plus 1 upon 4x minus 3. So, this 2 and 2 will be cancelled. On squaring, we will get, means the root will be removed, x plus 1 upon x minus 1, that will be equal to 16x square plus 8x plus 1, 16x square minus 24x plus 9. Now applying dividendo only, we get x plus 1 minus x plus 1 upon x minus 1. Here 16x square plus 8x plus 1 minus 16x square plus 24x minus 9 whole upon 16x square minus 24x plus 9. So we are left here, that is 2 upon x minus 1 is equal to upon 2 upon x minus 1 is equal to 32x minus 8. So this 2 will cancel the 32 and 8. So here you will get 16 and from here you will get 4. So by cross multiply we get 16x square minus 24x plus 9 equal to 16x square minus 20x plus 4. Now 16x square from right hand side and left hand side both are the same thing and having the same sign, hence it will be cancelled, and we are left here, that is 4x is equal to 5, and therefore the x is equal to 5 by 4. This will be the answer of the question number 8, fourth part.